Hi, my name is Wyatt Richards, and today we will be reviewing the scientific method. So, what is a scientific method? The scientific method is a process for experimentation that is used to explore observations and answer questions. The scientific method is generally 7 steps, although sometimes you can have more or less than 7 steps, and it usually does not occur in order. The scientific method more or less has been used since the 11th century by Muslim scholars, and Francis Bacon is famous for revamping it in the 16th century and making it more of what we use today. So this is the flowchart of the scientific method. So first you ask a question, next you do research. The most important step, in my opinion, is construct a hypothesis, because that's where the rest of the process starts. And then you start testing and seeing if your procedure works, and this is the area where you may need to loop back to constructing a hypothesis or retesting your experiment because something didn't occur the way you planned it to. So the first step. This is how you ask a question. You need to start it with the word how, what, when, who, which, why, or where. The process is much easier if it's number based, and it needs to be based on an observation. The second step, you need to do background research. So it helps if you have a plan so you can have a guideline for your research, and you need to find important, relevant information to make sure that you're not wasting your time. If you're using the scientific method in an education setting or in school, you need a bibliography for your final research paper. So here's step 3, the hypothesis. There are 2 main ways that you should format your hypotheses. If this, then this will happen, or this happens because this. The key points in a hypothesis are: you need to state the purpose of the research, identify what variables are used, and it needs to be logical, use precise language, and it needs to be testable with research or experimentation. Let's go to our friend Kurt and see his hypothesis on his experiment that he's doing.
The raspberries did not grow well this year because Donald Trump was elected.
Thanks, Kurt. If you want to create a good hypothesis, don't be like Kurt. Although Kurt did use the correct form, he did use precise language, and he kind of identified what variables are used. His hypothesis is definitely not logical, and there is no way to test the correlation between Donald Trump and raspberries. So now we will be moving on to the experimental phase. For the experiment, we want 2 different groups. The first group is the control group, where we leave the independent variable the same. The next group is the experiment group, where we change the independent variable to test our hypothesis. For example, if our hypothesis is the effect of pesticides in the growth of broccoli, the control group will just be regular growing broccoli, and the experiment group will be broccoli treated with pesticides. To ensure that we're getting accurate, repeatable results, we want to make sure that we do the experiment at least 3 times. The more you do it, the more accurate it will be. The next step is just to check on the previous step. Is the procedure working? If yes, you move on. If not, you need to fix the procedure. This step is to check if the experiment is working, not to see if the results match with the hypothesis. So the next step is to look at the results of the experiment and draw conclusions. So 2 things can happen here. If the results do align with the hypothesis, continue on to the next step. If they don't, you need to create a new hypothesis with the results of the experiment. Once the first 6 steps of the scientific method have been completed, you may proceed to communicate your results. You can use any method you prefer as long as your sources are cited. However, if you're in a classroom, you may need to use certain presentation forms, or you may need to write a research paper on your findings. So now we will be running through an example of the scientific method. So, can Andy Bernard successfully do parkour? To find this out, we may have to find more out about parkour and see if Andy is able to handle it. So our hypothesis is, if Andy Bernard attempts parkour, he will not succeed. Although we will not be able to do this experiment multiple times or have 2 groups, some experiments will not be able to have 2 groups, or will be able to be repeated multiple times due to danger of the subject. However, that is okay, and we will proceed on with the experiment. Let's see how Andy does.
Okay, we all go together, or we go one at a time.
Here it is. Truck to refrigerators to dumpster, 360 spin onto the pallets, backflip gainer into the trash can.
Yeah, gainer! Yeah!
Parkour! Parkour!
Parkour!
I'm right behind you, Andy! Come on!
Yeah!
Parkour. So for the final steps of our scientific method example, we were able to determine that the procedure works and the results align with the hypothesis. Now we may proceed to communicate our results. Thank you for watching.